Welcome everyone. My name is Karen and I will be your host for today's Encore webinar on Best Practices for Developing Smart Connected Products by Eric Ljung. We get asked this question a lot. Who is Room 5? So a little about Room 5 history. We specialize in helping our clients build smart connected products, leveraging our 19 plus years experience in mobile, cloud, embedded software design, and systems integration. Most of our projects involve working on our clients' next generation of products under strict non-disclosure agreements, and so we have been a secret, growing only through word of mouth through our excellent work. We started in 1995 as Tactile AB, a software consulting company in Sweden, working in the embedded devices and cellular infrastructure space with industry leaders Ericsson Networks and Sony Ericsson. We acquired a gaming company in 2005, which brought us deep expertise in 3D graphics, user experience, and user interface, which is retained today through our Swedish employees in the United States. And we opened our offices in the United States in 2007 to help develop the early smartphone for Sony Ericsson, which is the Xperia product line. We grew organically from there, adding to our embedded skills, developing on Android, iOS, Windows phones, and expanding into connectivity and integration into back-end enterprise applications and cloud services, which is now known as the Internet of Things. In 2013, Tactile US was renamed to Room 5. To introduce you to our presenter today, Eric Ljung, our Senior Development Director with Room 5. Eric joined Tactile in Sweden in 2006 as a software engineer and was promoted to software architect, technical lead, and now heads Room 5's development team. Eric personally worked on projects with Sony Ericsson, Qualcomm, Amazon, DARPA, L3 Photonics, and his team has delivered solutions to Intel, Amazon, Walmart, Sony, Samsung, BMW, and more. Eric's breadth of experience from mobile platforms, software middleware, frameworks, 3D graphics rendering, to working with low-level drivers, connectivity, and integration makes Eric an early IoT pioneer. Some fun facts about Eric. Eric wrote his first assembly language program at age 13. His favorite course at college was optimizing compilers. For his master's thesis with Philips Research, Eric built a mini-kernel with a distributed network protocol for smart cameras in 2005. He also served with the elite Swedish Air Force Rangers during his mandatory military service and spent 1 year in Austria during his ski bum days. Over to you, Eric.
All right. Thank you, Karen, for that introduction. And where I want to start today is what's the Internet of Things? So everybody reads a lot, hears a lot, everybody's talking about Internet of Things. For me and for us here at Room 5, it's turned into just a big buzzword and a marketing term. So I want to give you start this webinar by sharing our thoughts on it and what it really means to us and why we say, you know, building smart connected products and applications instead of the high-level Internet of Things. So what's a smart connected product or an application? So for us here at Room 5, you know, based on many years of building mobile, network, cloud, and various other services, we see how in IoT now and in the future, this is all sort of coming together in what we call smart connected products. And where we are today, in my opinion, is there's typically not a master reference architecture. And what I mean by that is take a smartphone as an example. A smartphone today comes in various forms, various shapes, and various operating systems. It could be iOS, Windows, Android, and so on and so on. But to some extent, there exists a master reference architecture. The platforms are pretty similar, They run the, similar large-scale operating systems. They provide similar services, obviously with a lot of different flavors, but there is a basic reference architecture to start building your smartphone on. Smartphones obviously span a lot of technical disciplines, which smart connected products also will do. The key thing here to be able to produce these type of smart products is two, right? It's understanding that this is, an n-dimensional problem, depending on how many technical disciplines you put in. It's also the challenge that large smartphone projects face is the various different life cycles of these type of software blocks, and also, the hardware piece to it. Here at Room 5, though, we focus on software, but we have a broad understanding on the life cycles of developing hardware as well, and how software needs to be sort of in conjunction with the hardware and aligned with various milestones. Another example would be, think about building an application. You can usually quickly iterate, short cycles, more an agile approach, where in embedded software you have much longer cycles and more through testing, and it takes longer to debug and figure out sort of architectural issues. The other area obviously is, in a smart connected product, you're now facing a lot of integration points because this is an n-dimensional problem. So that's just to give you some foundation of how we see an IoT project in sort of a more pragmatic way. So what's our approach then to sort of break down this challenge to actually building concrete stuff? Our approach is, obvious for a lot of you that have been doing this, but my experience is that it's not that obvious. It's very challenging, and it's easy to focus on the obvious thing if that's the obvious thing, right? So where we start usually is with the scope of the project. What are we actually trying to accomplish? What are we trying to build here? And this is totally opposite from a bottom-up design, where you start with what the building blocks you have and trying to build an architecture around it. And the reason for that is, as you look at the IoT market today, there are so many players providing so many various type of components for an IoT project. There are cloud services, there are embedded platforms being built, there are embedded and integrated cloud services. We see some of the big guys are starting to move now with ARM just releasing their embed suite. There's a lot of startups trying here. It's hard to figure out exactly what building blocks you should be using in your product. Again, that's why we want to start with a top-down approach. From the top-down approach, what we'd like to do is look at the primary use cases of this product or application, and try to identify the primary use cases that span these multiple technical disciplines. Because if we identify those, we can get answers to a lot of the questions that will drive the actual architecture of the system. And also, once you set that high-level architecture, you know what the type of building blocks you need to realize the primary use case. Then you can deep dive into each of the areas and have your previous experts in embedded or application or UX or whatever it is to deep dive in and set, like in traditional embedded, you obviously have a bill of materials, a power budget if it's a battery-driven thing. What are your memory requirements? Can you fit all the libraries in? From connectivity, is it persistent connectivity? Is there a gateway? What's the communication protocols you will be using? All these questions you can better answer if you have a high-level picture of what you're actually trying to build. What we see as an IoT project and our approach, I'll continue and give you a couple of examples. By the way, I'm very close to the train track, if you didn't notice. Apologize for that. We're broadcasting live from our lab here. So what I want to do is go through a couple of examples and how this sort of fits into what we've been doing. First example, it's what I call industrial assets calling home. So the use case is a set of industrial assets that already exist. They're deployed, they have some kind of data that they're collecting locally, but the challenge was to get this data up to the cloud for further monitoring and preventive maintenance. Now, that might not sound that complex at the first glance, so we started digging into what are we trying to do here? Do we have persistent connectivity through this use case? Yes, they wanted not real time, but constant monitoring of the assets. Is the data going back and forth? No, it was mostly a one-way street, data coming up to some centralized location. So looking at this is not so complex. So a typical mesh type of network would be applicable as the assets would be moving around, but in a controlled area, meaning that they will be in some kind of proximity to each other during the course of the network, meaning that we could keep a mesh network up so all the different assets could find their way home to the centralized unit. Based out of the facts we had, we could go and propose a mesh type of network based on Zigbee in this case, because it was battery and low power and there wasn't a huge amount of data being sent. The Zigbee mesh also gave us the option to be flexible on the actual gateway that takes this data back up to the cloud. So for instance, it could be a cellular gateway or a direct wired or Wi-Fi gateway to get out to the internet. So here's another example. It's called a smart construction site. The use case was an existing smart construction site with various sensors that are monitoring the actual construction. Data is being collected manually today, but the key thing here that data, it was not to replace the manual collection, because as the manual collection was being done, there's also visual inspection. So it was to optimize the use case and also be able to quickly send that data back to home office for further analytics. If we look at this and compare this with the previous example, a type of mesh network sounds very reasonable. So, but as we start scratching the surface here, a construction site usually don't have an internet backbone in place. That's not where you start building your building. So getting an IP gateway to get this data up to the cloud was not really reasonable here. Okay, we could have went with a cellular modem. Now looking at the sensors and how widespread they were, they could be out of range, meaning that there needed to be an infrastructure to create this mesh network. Looking at the use case, the construction engineer is going around doing visual inspection. This person could actually be the link to the mesh network. I'll show you this picture here. So what we ended up doing is that a little Bluetooth low energy dongle was created that could attach to the sensors and get the data. Because of the wireless connectivity to the mobile app, we could optimize the actual use case. And to explain this picture, you see there's two dongles, one to the left and one to the right. The left one represents a sensor that was left in a hard-to-get location. You can imagine a large construction site where you could have sensors that are in a very where-to-get-to physical location. In this case, we could just leave a dongle there and collect it when the construction was done to reuse. But the other dongle could be in the belt of the worker, so you could go and collect. This also added another nice feature that as data came into the mobile app, the construction engineer could get some first glance on how the site was doing. But we could also use the mobile phone as the gateway to push the data up to the cloud, and from there on push it to home office for further deep analytics. So this, when we looked at this from the beginning, it sounded like a mesh Zigbee type of play, but as we iterated on the use cases, we found a less expensive, more efficient way by using other technologies. And in this case, from a connectivity standpoint, it was Bluetooth low energy. Another example I have for you here is remote access to a smart controller. So imagine a kind of smart controller that already exists, doing some measurement and some controlling on some local premises. So we looked at the use case again and see, do we have multiple controllers per site? No, not really. So there was no real need for interconnectivity or a mesh type of style. What's the data rate? Is it a lot of data? Is it a power consumption? What's the power consumption? Looking at it, it was not battery driven, so we didn't have to worry about putting an RF technology that doesn't drain too much battery. And what was existing at the sites? There was Wi-Fi normally at the sites. So addressing this, we kind of narrowed into using a Wi-Fi chip on this. Now, as we further analyzed the use cases here, this wasn't as simple as just putting a Wi-Fi chip onto the smart controller, because various restrictions gave us some limitations. And one of them was that there could not exist any cloud features, meaning that if the mobile app or the remote application should not communicate through the cloud to the controller. And the reason for this was if the mobile app was on the same local network as the actual controller and internet connectivity went down, everything should still function fully properly. So we couldn't route any of the sort of features through the cloud. So what we ended up doing in this case was to use a very thin cloud service for remote access, meaning that the app is out on the cellular network or some other Wi-Fi somewhere, not the same one that the controller. This is a technique called hole punching that is used in most voice over IP protocols like Skype, Viber, and BitTorrent. If you're interested in this specific technique and learning more about it, we will follow up later in 2015 with either a blog post or a webinar specifically on this. But as you see here again, a use case that from beginning, that it's pretty easy to do bottom-up design, put some implications on it, so we had to take some work around, but be smart about them to not over-engineer things. The next example I have for you is a much more complex one, and this sort of ties into initially what I was talking about, how complex the systems are and how similar they are to how smartphones have evolved. So in this case, we have the next generation smart lock. And by next generation, I don't mean a lock that you just unlock or lock with your phone, because that exists already today. So let's take a look. Here, the use cases are quite a few that span the entire system. Just to give you a couple of examples, the idea was to be able to unlock the lock. Let's start with the fob. That's easy. You want to unlock and lock the lock when you're in proximity using a fob. Now the fob could be extended to a mobile app, which obviously could add more features, but the same basic use case. You also want to be able to unlock through Wi-Fi if you're somewhere remote. You also want to be able to unlock a lock remotely if you're on the cellular network. So the lock had to have some kind of backbone connectivity to the cloud, so we could talk through the cloud from the phone. Also, there was a web application that had both a user and an administrator interface. Imagine you're in a commercial building and you have 50 locks to manage. That's a totally different use case than you have one single lock in your home. So a lot of very different communication paths that were merged into the same. And to add even further on the complexity, now this webinar is mostly focused on connectivity, but I want to show you an example here. Think about the lock as, you know, having obviously the big area, which we will have a follow-on webinar on as well in 25, which is purely going to focus on security, power management. If you look at this from some perspective, it's actually taking an entire smartphone and putting it into your door to manage your lock. That's what we're looking at here. And so it's very interesting. And the way we addressed the biggest challenge here of having these various RF technologies, Wi-Fi, Bluetooth Low Energy, and Zigbee, and having all these use cases be similar, we built an overall messaging protocol. I know there's a lot of messaging protocols existing out there, and there's new ones coming that are trying to address everything on, that are connected, can talk the same. I don't see those protocols are mature enough to be used. There's a lot of good initiatives like the All Scene Alliance and so on, but I don't see them are fully ready for production type of software. So in this case, we designed a very thin but our own messaging protocol in the top layers of the stack. So basically the fob can send the same message as the administrator on the website, so the lock interprets it further down in the stack to actually unlock or lock the door. My last example for you here is what I call the other way around. So I won't start with any use case or what this was built for. I'll start the other way around because that was how this project was designed. So a sensor mesh was designed that was creating a huge data stream, real-time data stream, and our assignment or our challenge in this project was to build a data aggregation and a filtering of that data and show it in a mobile app. So the sensor mesh was already built and under heavy development when we came on board, and our first look at it was to figure out how we can present this data and get this data out. Now, the sensor mesh was, each node was created with one Bluetooth and one Wi-Fi interface. The Wi-Fi interface was an older one, which means we couldn't use Wi-Fi direct, and it's also a limitation on most of the mobiles at the time. Bluetooth, it was not Bluetooth Energy, which meant we have to fall back to the old stack and do manual pairing and stuff. So as we tried to design use cases around this, the technology was picked already early, was limiting us, and we had no options to change that. So as you see here, we had to do quite a lot of workarounds. For instance, on the mobile app, we had to try to make as seamless as possible Bluetooth connectivity, and also as you were walking around in this mesh, you had to sort of decouple from one node and connect to another one. Also, the data aggregation could not be centralized because if you're on a Bluetooth link, that data aggregation had to be on the mobile phone directly, and the mobile phone is not as powerful, obviously, as the backend server farm. With Wi-Fi, you know, the mesh could be deployed anywhere, so, and there was not assured that there was a backbone. So in this case, the actual server was deployed with the mesh, which is not a beautiful setup. Imagine you're far out somewhere and you're moving a sensor mesh around. You don't want to have your server part close to the actual mesh. But that was needed to really get the full power out of the algorithms that were aggregating and filtering data. So this gives you an example of how a bottom-up approach took us, as we were coming up through the stack, to do very, very weird workarounds and designs to be able to deliver what we were supposed to deliver, but still in an efficient way. So this is my take on where we are with IoT at the moment. Take a few seconds to read it through. And I do want to make the point that I believe there will be really good standards and protocols out there. But in the meantime, connectivity is going to be a very tough challenge for anybody who wants to build a smart product, and making sure that you bet on the right technology early on. So a quick summary from my side here. Start with the scope of what you're actually building and try to figure out your use cases that span multiple technical disciplines, because then you can set that high-level architecture, and based out of that you can move down further into those subcomponents and architect them, and obviously iterate this so you get a high level. Because as I mentioned earlier on in this presentation, it could be as complex as building an entire smartphone, and we all know how many millions of man years, I was always about to say, that have gone into engineering the smartphones that we have today, right? And if you're one of those solution architects that are being tasked to design those systems, I think it's critical, even if you come from an embedded background or from an app or a cloud, give yourself a broad understanding of these various building blocks, because the architecture will have implications on other parts of the system. And again, this might sound obvious, but my experience as a consultant being brought into various projects, it's usually not always the the sort of primary path that people take through the process here. So that was all for me today. I know it was short and was focused on a couple of examples and specifically around connectivity. But thank you, everybody, and handing it back over to Karen.
Okay, we did have one question that came in on Twitter. What are the concerns about security with IoT?
So I know there's a lot of concern about security, and what we try to do is look at, so by doing a set of these projects now for the last couple of years, we have built an experience base, and where we base most of our architectures on is reference architectures that we have in-house that look similar to once we've identified the use cases. And when it comes to security, there's two things that I would recommend for anyone that are concerned about that, or actually three. Let's start by always consult experts. So we are, experts in integrating these solutions and building smart products. That doesn't mean that we're expert in security. So even if we have a lot of experience gained over the years, we always consult third-party security experts to audit our work before we put it into any product. And two of the main things that I learned there is obviously go with as much off-the-shelf security products as possible that match the hardware capabilities you might have, and don't try to reinvent the wheel. The other one that I learned is it's very critical to have as we've seen with the recent breach-ins to Apple had security issues with their servers and so on, that having an option to be able to upgrade your software after it's been deployed. I mean, it's what's called firmware over the air or upgrade over the air. So because security is not if you build a product and say, well, this is secure, that's a snapshot in time, right? Things evolve, new exploits are being found. So security is a program. It's not a task you solve in the product. So giving you that options to update the software as you go on is critical to keeping your product secure down the road.
We unfortunately do not have time to answer any more questions, but please feel free to contact us if you have any other questions, and we will answer them offline.